Hey everyone, so the purpose of this video is to go over conversion and mathematical instruction sets when programming with Proficy Machine Edition version 9.5 to program an Emerson RX3i PACSystem controller, notably the IC695 CP305. Now when it comes to conversion instructions, we're going to be touching base on how to convert from an integer to a real value and vice versa, as well as a uint to an integer as well. And then for mathematical instructions, we'll be covering some basic, your adds, your subtractions, multiplications, divisions, and then looking at the scaling instruction. So without further ado, let's get started. Here I have a very simple program in Proficy Machine Edition version 9.5. I have a simple hardware configuration with a power supply, controller, and network module, and then a single program block, which is our main routine. Now what I've gone ahead already is I've created the instruction sets for converting integers to reals, vice versa. So that'd be a real to integer, and then a uint to int. And all I've done basically is create the instruction, and I can just replace it and just show you it's int to real. So int to real, that's basically the instruction. And then real to int is real underscore to underscore int, and then uint to int is just uint underscore to underscore int. And what I've done is I've just created a few basic variables, like an integer, my real 1, my real 3, my integer 2, and so forth and so forth. So let's just start off with the integer to real conversion. If I write a 1 here, well, 1 converts very nicely as an integer to 1.0 for a real value. If I write 16,000 here, then it's 16,000 on the dot. Now, if I write a 32,767, it's going to convert to 32,767 all for the real value. Now, let's consider real to integers. This is where we have to be a little bit careful, because when you're moving now from real to integer, we have to be aware of the maximum range of our variables. So as a real value, yeah, sure, I could put 16.5 and I'll round it to 16, or I could put a 16.6 and I'll round to 17. And if I do a 17.99999, I'll just round it right to 18. But what happens if I write, say, 200,000 in this? Well, what's going to happen is there's actually a maximum range in terms of memory space for a data type of type int versus type real. And in this case, an integer can only have a maximum value of 32,767. Therefore, when you try to write anything larger than that, it's going to bound it to its maximum. And conversely, if I make this negative 200,000, so put a negative here, it'll write a negative 32,768 on my integer 2 variable, because negative 32,768 is the minimum boundary for a typical integer data type. Same thing holds true when we're looking at uints and integers. Now uints have a range of 0 to, I think it's 65,500 and is it 35? Or is it, oops, just make sure, is that right? Yeah, 535. And integers have a maximum upper boundary of 30,767. Now if I make this a 0, then, well, that's fine. But if I make this, say, a negative value, you can't have a negative value for a uint data type. So just be aware of when you're converting from one data type to another that there are restrictions on the ranges that you can convert from, which may result in unexpected conversions if you're not tracking them, if you're not accounting for them in your logic. Now let's jump to simple mathematical instruction sets, like additions or subtractions and so forth and so forth. So let's just start off very simply with some addition instructions, and there's an addition instruction for different types of data types, like reals or integers or words, etc., etc. So let's just use a real instruction. What would happen if I use an add real and I want to add 2 different real registers together? So let's see, my underscore real 1, and I want to add that to my underscore real 2, or I just wrote 32 there, but we'll just leave it, that's fine. My underscore real 4. And if we accept this, the instruction set works by taking in1 and adds it to in2. So if I do, say, oh, right, that's being influenced by this guy. So let's just make this say 16. So what is 16 plus 15? Well, that's 31. How about 16 plus 15.5? That's 31.5. So it's a really, really, really simple to use instruction. You're just adding 2 real data types together, and on the output side, the Q is just the summation of the two. That's basically it. For subtraction, it's just the inverse. So if I do a subtract real, it's in1 minus in2, which produces an output Q. So 16 minus 15.5 is 0.5. If I use a division, so do div real, 16.0 divided by 15.5 is going to be 1 point followed by a whole bunch of zeros, so 0.032258. And what you have to be aware of is if you divide by 0, what would happen? If I put a 0 here, it's going to give you an error. It's a 1 point infinite, it's an infinite number. So what you really should be doing is whenever you're doing any logic execution for division, always ensure that you're checking the variables that you're dividing against before you execute the division instruction, where you could do something like, as long as the denominator, the in2, is not equal to 0, then you can execute your division instruction. This is so you just don't run into unexpected errors in your logic, which could have effects on any downstream logic. So there's very simple division, and let's do multiplication. So it's MUL real. So MUL real for multiplication. So 16 times 1 is, well, it should be just 16. And if we do, how about 2.5? Well, that's 40. How about 2.55555? 40.888. And how about like 80? So we know the multiplication is working fine. And mind you, you could also have the output from one instruction become the input for another instruction if you want to have complex arithmetic operations. So I can have this say a div real, and maybe I want to take whatever my result is and divide it by 5. Why not? So if I do that, if I just store that into my real 4, and now all I'm doing is I'm taking the result and dividing it by 5. Q links in with N1, divided by 5, results in 256. So if I do, what's 16 divided by 5 is basically 16 times 1 divided by 5 is 3.2. And then if I just get to say, I don't know, say 30, 30 divided by 5 should be 6. So we're great. So that's how you use very simple mathematical instructions. Let's do finally the scaling instruction. So that's going to be scale. Let's do a scale. Let's do a scale integer actually. And we'll do a couple scaling instructions. So how this works is it's basically scaling on an input with its own span to an output with its own span. So imagine this. Suppose my input value, I'll call this input integer. And suppose the input has a range of 0 to 100. And the output range has an output of 0 to 32,000 on the high. So I'm basically converting from one input with its own respective range to an output with its own respective range. So imagine this. If input is, say, 50, 50 should convert as its input side to 16,000 on the output, because the range on the output is 0 to 32,000. So let's call this output int, just so we can see this in action. So basically, it's as if I'm converting a percentage, 0 to say 100%, to say some value as 0 to 32,000. So let me see here. Our input is currently 0. What if I make it 50%? Then it should be 16,000. If I make it 30, if I make it 100, then the output is 32,000. Now what happens if I go beyond the range? Say I make it 150. What happens on the output? Well, we're actually restricting it to the maximum side of the output because we've done that through our scaling instruction. What if I make this negative 500? What happens on the output? Again, we've restricted it to be within that span. So this way, the scaling instruction only scales your input to an output within a certain range. Now, let's suppose I were to use a different instruction, and I call this just, I think it's called scale, where is it? Scale int, range. No, I don't think it actually exists. So this is basically a simple scaling instruction. Now you might want to consider, well, what if I want to scale an integer to a real value? And this is very, very common, especially when you're conditioning raw signals from a PLC. Now when it comes to Proficy Machine Edition, whenever you're scaling raw input, like analog input signals from, say, some sort of analog transmitter, typically you would scale it from an integer value to a real value. And the integer would typically come in as 0 to 32,000 counts. and you'd scale that accordingly. So imagine this. If I wanted to do that, then you could do this way. So let's remove this instruction. And what we're going to do is we're going to add a scale real instruction. Oh, sorry, make sure I did that right. So a scale underscore scale real. No, I don't think it exists. Okay, let's use a multiply real instruction. And what we're going to do is we're going to assume it this way. We're going to take a signal and we're going to move it from integer to real. So we'll do int to real. So we're going to convert our integer, which again is 32,000, 0 to 32,000. So my integer, say 99, and convert this to my scale me, just to say this is what we want to scale. And we're going to basically multiply this. So what's going to happen is this will execute first, then we'll execute our multiply real instruction. And what's going to happen is we take the output from scale me, which is a real value, we plug it into our multiply real, and what we're going to want to do is, actually before we multiply this, we're going to want to actually divide this first of all. So let's do a division real. So this is 0 to 32,000. So if I make this 32,000, this is going to get us into basically a percentage. So this will be my percentage. And then as a percentage, we can then do something with it to convert it to some sort of engineering value. So let's say we'll do a mul real. And we'll just add a wire here. And we'll add the my percentage here. And let's just say we're converting this to a value of, say, 0 to 1,000 kilopascals. That's how we're getting this transmitter. So why don't we add a comment here, and we're just going to say converts from 0 to 32,000 as an integer to 0 to 1,000 kilopascals. Because maybe this is a pressure. So my pressure. So what we're going to do is take the integer. Oh, I made some errors here, so let's just quickly check to see. Rung 5, disconnected instruction sets. My 5, make sure there's nothing weird here. My int to real, that looks okay to me. Int to real looks okay, looks fine. And, okay, sorry. This is what needed to happen. That was incorrect. Okay, so we'll save this and let's see what happens. We're going to take an integer value, say 16,000, which is converted to a real value. Then we divide it by 32,000 to get 50%. 50% times 1,000 as the maximum span for this transmitter in kilopascals results in 500 kilopascals. If I make it 32,000, it should be 1,000. If I make it 1, it would just be basically the resolution of the transmitter. So if we see any change, it can detect 0.03125 kilopascals. And that's basically it when it comes to using arithmetic operations. So I hope this video was helpful for you, and thanks for tuning in.